Hi there science students. In this video we're going to bring together the skills we've learnt in the previous two videos. So that involved calculating a number of moles from a given mass and deducing the mole-to-mole ratios for a reaction by balancing that reaction. Now this question involves a certain mass of ethene gas that's completely combusted in plentiful oxygen, and we're asked how much oxygen is required for the reaction. And the second part of this is how much CO2 is produced in the reaction. Now, we're required to understand what the reactants and products are from the description here. 50 grams of ethene gas completely combusted in plentiful oxygen. That means that the products, of course, will be CO2 and H2O. And because it's a combustion reaction, this hydrocarbon, ethene, will be reacting with O2 gas. Now, we see the steps here. Right? Now, these questions are quite involved, but if we practice these steps enough, we can start to see that there's actually quite a distinct pattern and logic to this, even if at first the question seems just to take a set of random steps with no rhyme or reason. What we're actually doing, once we've balanced this equation, is we're converting from mass of ethene, so mass to moles, using this equation here. Then we do our mole-to-mole ratios, so use the reaction again, and then we want to find the mass of O2, so we go from moles back to mass again, using that form of the equation. So what we're doing is, rather than comparing mass to mass, we're comparing number of moles to number of moles, and that is a lot easier. And this is where the true magic of moles comes to the fore. So you're just going to have to wait to see and witness that occur in this video. So why don't you guys go ahead, pause the video, and complete step 1 by writing down a balanced reaction for this scenario. Then I'll have a go at it. Okay, so 50 grams of ethene gas. Ethene is C2H4. In a combustion reaction, it will react with oxygen, and because we have plentiful oxygen and it's complete combustion, that means CO2 and H2O are produced. Now, if you hadn't gotten that far, maybe you want to pause the video and try balancing this one yourself, then I'll do it. Righto, so you may be getting a feel for these ones by now. The idea is to balance the carbon, then the hydrogen, then finally the oxygen. So the carbon, 2 this side, 1 this side, so we'll put a 2 there. The hydrogen, 4 this side, 2 this side, so we'll put a 2 there. So that means for the oxygen, on the right hand side, we've got 2 by 2 is 4, 2 by 1 is 1, makes 6. So if we put a 3 here, we've got 6 on both sides, and we're all balanced. Okay, so we've got a balanced reaction. Step 1 is complete. Let's leave the reaction for now and use our known mass of ethene and this equation here to find how many moles of ethene we have. So pause the video and try that, then I'll do it. Okay, so number of moles of ethene is equal to the mass we have, which is 50, divided by the molecular mass of ethene, which is, okay, we've got 2 lots of carbon at 12 each, and 4 lots of hydrogen at 1 each. So we're going to be doing 50 divided by 28. Now I think I might have done that before. 50 divided by 28. I'll do it again. Oh, here it is over here. Anyway, 1.79 moles. To three significant figures. So we'll start using those three significant figures now that we've learnt about those. Okay, so we've got the number of moles of ethene. What we're interested in though is oxygen. So we're going to use this to calculate the number of moles of O2. So that means looking at the mole to mole ratio of ethene to oxygen. Can you figure what that is? So there's an invisible 1 in front here. So that means the ratio is 1 to 3. So we take the number of moles of ethene and multiply it by 3, and that gives us the number of moles of oxygen. So 1.79, bear with me, 1.79 by 3, 5.37 moles. Okay, so now we've got the number of moles of oxygen. If you have the number of moles of a substance, you can use this equation to calculate its mass, and we'll have finished this problem. So go ahead and try that, then I'll do it. Okay, so the mass of O2. So mass of O2 is equal to the number of moles, 5.37, times the molecular mass of oxygen, 2 lots of oxygen, 16 each, so 5.37 by 32. Times 32, 171.84. Can you convert that to three significant figures? 172 grams. Okay, now the next part of this is very similar. So you might want to pause and try this on your own, and then I'll go through the whole thing in one go. Okay, so firstly, we want to figure the number of moles of CO2, so that's the mole ratios in the reaction. If we look back, the mole to mole ratio is 1 to 2 between ethene and CO2. 1 to 2 ratio. Okay, so that means the number of moles of carbon dioxide is equal to 2 by 1.79. .58 moles. Okay, so now that we've got the number of moles of CO2, we can calculate the mass. We've got 3.58 times, okay, 1 lot of carbon, which is 12 each, plus 2 lots of oxygen at 16 each. So what's that? 32 and 12 makes 44. So 3.58 by 44. 157.52 grams. Three significant figures. 158 grams. Okay guys, so go ahead and try the question that's in the description for the video. It's in the stoichiometry notes that were given out, and follow those steps to complete that question. In fact, we'll have a go at 2 questions in there, One of them's a combustion type reaction, which is really similar to this one. The other one is a precipitation reaction. Now, that might throw you a little bit, but let's give it a go and see if we can figure it out. It works all the same way, but we just have a different reaction at the beginning. Okay, thank you.